Hello, in today's video we're going to be talking about the law of conservation of mass. Now this is a mass law that comes up regularly in chemistry, be it general chemistry, physical chemistry, analytical chemistry, any of the realms of chemistry. So what we want to do is we want to understand how this works, and it does come up all throughout this whole semester, and it'll come up in odd ways. So I'm going to show you a few simple ways that we can use the law of mass conservation, and then we'll move on to some of the other mass laws in different videos. So what is the law of mass conservation? If we have two reactants, this is reactant A, this is going to be reactant B. When they react together, they're going to form a new product, and we're just going to call that product C. This is one type of a reaction. Later on in the semester, we'll learn how this type of reaction handles, how we can handle this type of reaction. But for now, just take my word. Some reactions have two reactants combining to form one product. So if we knew the masses of A and B, let's say A was 7 grams, and let's say B was 2 grams, by the law of mass conservation, the total mass of the reactants, which in this case would be 7 grams plus 2 grams, which equals 9 grams, has to be equal to the total mass of the products. So the mass on this side of the arrow has to be equal to the mass on this side of the arrow. So here we know that this mass of C, we automatically know that C is going to weigh 9 grams because the total mass over here has to equal the total mass on the left. So we know that the total mass over here is going to be 9 grams as well. So we can put in 9 grams in this for the product of C. So this is a very simple type of a mass law, but it has huge ramifications. If we know 2 out of the 3, if there are 3 different if there are 2 reactants in one product, if we know 2 out of the 3 of those, we can always solve for the third one. So let's do a problem like that. Let's take our same reaction. A plus B is going to give us C, but we're going to change what the masses are. So we're going to have A is going to have a mass, let's say, of 8 grams. And we know that our product, we're going to be in a laboratory, we weighed out A, we forgot to weigh out what B was, but we got a product, and we knew that the product weighed 17 grams. How can we figure out what the mass of B was? This is going to be an unknown. We're going to solve it for X. We're going to set an X in there. Now, a lot of times in mathematics as well as in chemistry, we use X as our variable as the thing that we're going to be solving for. Now, I want you guys to get used to solving equations using those variables and then plugging in numbers at the end. You'll see why that will make sense once we get into chapter 5 and later. So the further along in mathematics, the further along in science you get, the more difficult it's going to become to plug in numbers right off the bat. Well, we had a simple equation. We knew that the total mass on the left has to equal the total mass on the right. We can plug in our masses. The total mass on the left is going to be 8 grams. We're going to add to that X grams. We don't know how many grams that is. And that has to be equal to 17 grams. Total mass of the left, 8 plus X, has to equal total mass on the right, 17. What we can do now is we can solve for X. The way we do that is we subtract 8 grams from both sides, and we get X is going to be equal to 9 grams. So now we know that B has a mass of 9 grams. So we can replace that X with 9 grams. So what we in effect did was we performed a reaction. We had 2 reactants, A and B. They formed a product, C. We knew what the mass of one of the reactants was, and we forgot to measure the mass of the second reactant, but we measured the mass of the product. We can always solve for the mass here. Now, this is a very simple type of an example of how we can use the law of mass conservation. We'll deal with a few more complicated aspects of this a little bit later on in the semester.